Welcome. In this video we'll be solving trigonometric equations involving cosecant part 3. Let's take a look at our first example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here the equation is 5 minus 3 times cosecant of negative 2 theta is equal to 2. So the first thing we want to do is to leave the cosecant by itself. So let's go ahead and subtract 5 from both sides of the equation. That leaves you with negative 3 times cosecant of negative 2 theta is equal to negative 3. Our next step is to divide both sides of the equation by negative 3, so we can isolate the cosecant. Thus, you get that cosecant of negative 2 theta is equal to positive 1. Our next step is to rewrite cosecant in terms of its reciprocal function. So cosecant is the same as 1 over sine. So we can rewrite this equation as 1 over sine of negative 2 theta is equal to 1. Now let's take the reciprocal of both sides of the equation to get an easier equation to work with. So the reciprocal of 1 over sine is simply sine of negative 2 theta, which is equal to the reciprocal of 1, which is 1 over 1, which happens to be 1. Now at this stage, let's go ahead and introduce a new variable alpha. So let alpha be equal to negative 2 times the theta. Hence, this equation becomes sine of alpha is equal to 1. So we want all the angles alpha such that they have a y-coordinate corresponding to it of 1. To figure out what those angles are, let's go ahead and take a look at the unit circle. So we want the point with y-coordinate of 1. Well, that point happens to be this one. So the corresponding angle is pi over 2. Therefore, we can conclude that alpha is simply equal to pi over 2. Now, solving for theta, we can actually get a value for our angles. So, using the fact that alpha is equal to pi over 2, solve for theta. Okay, so let's go ahead and use the previous definition, so we can say that negative 2 times theta is equal to pi over 2. Why? Because alpha is exactly the same as negative 2 theta. Now let's divide both sides of the equation by negative 2, so we can get the actual value for theta. In this case, we get that theta is equal to pi over negative 4, or simply negative pi over 4. Now this angle is not on the interval from 0 to 2 pi. So what we need to do is to add the period of the original function. But our original function dealt with an input of negative 2 theta. Well, to figure out the period of that function, we take the period of cosecant, which is 2 pi, and we're going to divide by the absolute value of the coefficient of theta. In this case, the coefficient of theta is negative 2. So let's divide by the absolute value of negative 2. Now this becomes 2 pi divided by the absolute value of negative 2, which is 2. So the period of the original function is equal to pi. Now we're going to use this period to add it to the previously obtained angle to get our actual values of theta that happen to be between 0 and 2 pi. So theta is equal to negative pi over 4 plus pi, which is the period. Now let's multiply that pi by 4 over 4 so we can get the common denominator, and this is simply negative pi over 4 plus 4 pi over 4, which simplifies to 3 pi over 4. So this is one of the angles that we want to use. The next angle would be found by using this measure plus the period again. So we take the next theta to be 3 pi over 4 plus the period of pi. Let's multiply that pi by 4 over 4 so we can get the common denominator, and this now becomes 7 pi over 4. So these are the two angles that happen to be solutions to the original equation on the interval from 0 to 2 pi. How do we know that? Well, if we were to take another angle, okay, theta, to be 7 pi over 4 and add the pi, which will be pi times 4 over 4, you get that the next angle will measure 11 pi over 4. But 2 pi, it's equivalent to 2 pi times 4 over 4, which is simply equal to 8 pi over 4. So this third angle will be surpassing this particular value of 2 pi. Therefore, we can say the following. We can say that the angles that will be solutions to the initial equation on the interval from 0 to 2 pi are simply equal to 3 pi over 4 and 7 pi over 4. Let's see another example. Example 2. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So once again, let's go ahead and isolate the cosecant. Let's leave it by itself. To do so, let's go ahead and subtract the 1 from both sides of the equation. So we get that cosecant of 2 theta is equal to 2. Now using the definition of cosecant, we can write this equation as 1 over sine of 2 theta is equal to 2. And taking the reciprocal of both sides of the equation, we get that the reciprocal 1 over sine of 2 theta, it's simply sine of 2 theta, and the reciprocal of 2 is equal to 1/2. Now, let's go ahead and introduce a new variable, alpha. So let alpha be equal to 2 times theta. Then this equation becomes sine of alpha is equal to 1/2. In order for us to solve that one, we can say that we want the angles alpha that will have a y-coordinate of 1/2. So we take a look at the unit circle here, and we look for any point that has a y-coordinate of 1/2. Okay, we notice this is one of the points, and the reflection across the y-axis is another point. So we get from here that alpha could be either pi over 6 or 5 pi over 6. Now we need to use those two values to get the theta by itself. Okay, so let's take a look at the at that particular case. So using alpha is equal to pi over 6, solve for theta. So we have that alpha was defined to be simply 2 theta, so we can replace that with the 2 theta, and that is equal to pi over 6. Now to get the theta by itself, let's go ahead and divide by 2 on both sides. So we get that theta is equal to pi over 12. Now to get the next angles, we need to add the period of this original function. Okay, so cosecant of 2 theta. Recall that the period of cosecant is 2 pi, so we're going to take the 2 pi originally, and we're going to divide by the absolute value of the coefficient of theta. In this case, the coefficient of theta happens to be 2. So let's take the absolute value of 2. That is 2 pi divided by 2, which is pi. So the period of this function, cosecant of 2 theta, happens to be pi. So let's go ahead and add the pi to it to get the next angle. So we have theta is equal to pi over 12 plus pi, which it happens to be the period. Let's multiply this one by 12 over 12 to get the same denominator. So this now becomes 13 pi over 12. Now, to make sense of when to stop, let's recall that we want the values to go to 2 pi. Well, 2 pi happens to be 2 pi times 12 over 12, which will give you 24 pi over 12. So let's check the next value here. If we were to take theta to be 13 pi over 12 plus another pi, let's multiply that one by 12 over 12, we get that that is now 25 pi over 12, which is surpassing the limit of 2 pi. So we only take those two values for theta, given that alpha was pi over 6. But let's recall that we had another value for alpha. The other value for alpha is 5 pi over 6. So let me fix that in there, using alpha to be 5 pi over 6, solve for theta. Okay, so we know that alpha was defined to be 2 theta, so let's replace that with the 2 theta, and that is equal to 5 pi over 6. Now, dividing by 2 on both sides to get the theta by itself, we get that theta happens to be 5 pi over 12. Now, to get the next angle, what we can do is to add the period, but we already found that the period of the original function was pi, so we take the 5 pi over 12, and we are going to add pi. Now, this pi, we're going to multiply by 12 over 12 so we can get the same denominator, and that now becomes 17 pi over 12. What would happen if we actually added another pi over 12? Well, you would end up with 17 pi over 12 plus 12 pi over 12 will be 29 pi over 12, which is surpassing the 24 pi over 12, which represents the 2 pi. Therefore, we're going to take this 4 to be our solutions on that particular interval. So we can say that theta is equal to pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And ladies and gentlemen, this concludes our video on how to solve trigonometric equations involving cosecant part 3. Thank you for watching and have a wonderful day.